Okay, so this is a revision of reflection, one of the easiest chapters in your maths textbook. So you have reflections on different planes or lines. Okay, so if you look at a graph, you have the y-axis, you have the x-axis. There you have 5 types of reflections in this chapter. The first reflection will be along the x-axis. Okay, so say you take a point 2 comma 1. Okay, that means 2 on the x-axis and 1 on the
One on the
y-axis. So if this point reflects on the x-axis, what will it be? Where will its reflection be seen? Down? Huh?
-2. No, 2 comma -1.
Yeah, so the reflection on the x-axis will be over here, right? So on this axis, the 2 will remain as 2 itself, but this 1 will be what? -1. So 2 comma -1. Okay. So a point 2 comma 1 on reflection on the x-axis becomes 2 comma -1. So what do you notice? Just observe the change. On the x-axis, the y coordinate will change its sign. Just memorize it that way. On the any reflection on the x-axis, the y coordinate sign will change. So similarly, if any point reflects on the y-axis, what's going to happen? 2 comma 1, what will it become?
-2 comma
-2 comma 1.
-2 comma 1. So in the diagram, where would it be? 2 comma 1 would reflect on the y-axis, so the reflection would be seen over here. Right, this is -1, this is -2. So there is x value is -2 and the y value is 1. Okay. Then the third
Now
clear?
there's origin also, right?
origin.
Yeah, that's next. Okay. Now reflection on the origin. What is origin?
X-axis and y-axis both change the.
So this point, this is the origin. So any reflection on the origin, it will be seen over here. See straight across the origin. Okay. So what will be the coordinates of the point? -2, -1. Okay. So on the origin, both the values change. X and y both will change sign. If it's minus, it becomes plus. If it's plus, it becomes minus. So these are the 3 out of 5. Okay, these are the easy ones. Then you have reflection over a line. Okay. For example, a line x is equal to 1. So what is this line x is equal to 1? How do you draw such a line? So x is equal
Parallel to y-axis.
Okay, so x is equal to 1 will be a line parallel to the y-axis passing through the point x is equal to 1. Because anywhere on this point, the x coordinate will be 1. Correct? All right, so how would this point reflect on this line? How would this point 2 comma 1 reflect on this line here? Okay, so this point is 1
Leaving one
centimeter.
space.
Yeah, it's 1 unit in front of it. So its reflection will be 1 unit behind. This is where its reflection will be. Okay, so what is the coordinate of this point? Huh?
0 comma 1.
On the x-axis, it is 0. On the y-axis, 1. So that is 0 comma 1. So this, it's not simple as just changing the sign or anything. You have to actually draw the graph and then see how front it is, that much back it will be. Okay. For the first 3, you don't need graph. You just have these rules. Right. What's the rule, Aman? Reflection on the x-axis, what will happen? Sign of x-axis. X-axis. What is x-axis number? This 2 is called the x coordinate and the 1 is called the y coordinate. Okay. The x coordinate is also called as abscissa and the y coordinate is called ordinate. Okay. So any reflection on the x-axis, what changes, Aman? The ordinate changes. And any reflection on the y-axis, the abscissa's sign changes. And any reflection on the origin? Yeah, both change. Then only for this line that you draw x is equal to something, or the fifth one is y is equal to something. Okay, say for both of these you have to draw a graph, and on the graph only you'll be able to figure out where the reflection is. Okay, so let's say a line y is equal to -2. Where will the point 2 comma 1 be if you reflect it on the line y is equal to -2? So y is equal to -2 will be here. Right, this is y is -1, y -2 is over here. So where will the reflection of this be, of this point? Come on, tell me. Waiting, come on.
Wait, Anna, where is the point?
Same point, 2 comma 1, reflecting on the line y is equal to -2.
3 points below the -2.
So where is it? Tell the point. Anyone else?
-2 comma
-5, 1.
No, Nathan.
-2 comma 2.
Then the camera is on, all of you.
1, -5.
Wait, there's a
No, wait, sorry. 2, -5.
come on. 2 comma 1. That's it. So 2 comma 1, see it as reflecting on this point. So it will come that many points down. See, it's 3 spaces on top. No, see 1, 2, 3 spaces. So it will go 3 spaces down.
So 2, -5.
Yeah, 2 comma -5. 2 will not change. 2 is the x coordinate. That won't change. The y coordinate will change. Okay, so it goes, this is -2. So it will go -3, -4, -5. So 2 comma -5. Okay. It's okay. It's okay. It's okay. It's okay. It's okay. Okay, so this is the theory part of this chapter. Now, how will you draw this? Or what type of questions come here is where you have graphs, and they'll tell you to reflect a certain point on any one of these 5 planes. Okay, so not one point that you're reflecting. It might be 2 points. It might be 3 points. Might be how many other points? Yeah. So, like for example, in this question, A, B, C were given, and they asked you to reflect A to A dash, B to B dash, and C to C dash. Okay, so on what plane was this reflected? On the origin. That's why it crossed over and came here. Then they might tell you reflect A dash on the y-axis to get A double dash. Or they might say reflect A on the x-axis to get A double dash. Okay, so like that you reflect all these points, you'll get different points. Mark the points. You might have to join the points, and then they'll say join some things like join B, B double dash, C double dash, C. So when you join this, what shape are you getting? It's a trapezium. See, 2 sides are parallel, other 2 sides are not parallel. In fact, it's an isosceles trapezium because, is it? Yes, it's C double dash, B double dash, and here also C to B. Okay, so these 2 sides are equal. CB and C double dash, B double dash are equal in length. So this is an isosceles trapezium. Then they might ask you to find the area of the isosceles trapezium. Okay, so you need to know formulas for area also in this chapter. Okay, so what's the formula to find area for an isosceles trapezium? Half into sum of parallel sides multiplied by the distance between the parallel sides. This is a formula for area of trapezium. How many of you remember this? No one remembers it? So half into sum of the parallel sides. So which are the parallel sides? This one and this one. So what is this height? What's the distance from C to C double dash? 2 units. Okay. Plus from B to B double dash, how many units? Oh, actually, wait. This is not 1 unit. See, this is 2 to minus 2. So 2, 1, 0, minus 1, minus 2. So how many units is that? It's 4 units. 2 to minus 2 is 4 units. And this is from 4, 5 to 4 minus 5. How many units? 10 units. 5 to minus 5. How do you get the number of units? It's just a big number minus small number. That's it. So here 5 minus 5. That's 5 plus 5, 10. Multiplied by the distance between these two. So to measure the distance, we need to see the x-axis values. Here, what is the x-coordinate? 4. Here, what's the x-coordinate? 7. So 4 to 7 is how many? 3. Okay. So like that, you can put the values and solve it. So 1 by 2 into 14 into 3. 7 into 3, that is 21 square units. Because we don't know what the unit is. If it's centimeter, then square centimeter. If it's meter, square meter. It's units or square units. Is that clear? See the answer here. 21 square unit. If it's a parallelogram, what's the area of parallelogram formula?
Half into
Parallelogram, this is a parallelogram. Area formula is what? It's base into height. You need the height. Perpendicular distance to the base. Formula is base into height. Any area formula is product of two perpendicular sides. Okay. Provided that the perpendicular sides are equal in length. Okay. So here, see, this is one perpendicular side, this is another perpendicular side. So one perpendicular side multiplied by the, sorry, not perpendicular. One of the parallel sides, both should be equal. So one parallel side into the perpendicular distance between the two sides. Okay. How did that work for a trapezium? For a trapezium, see, both the parallel sides, they were not equal in length. That's why we have to find the average of both the sides. How do we find the average of both the sides? This side plus this side divided by 2. So that's what we're doing here. Sum of parallel sides and divide by 2. Multiplied by the distance between them. That is the distance. So it's the same formula for area for any shape, whether it is a square or a rectangle or a trapezium or a rhombus or anything. What's the general formula to find area, any shape? This side into this side, multiplying two perpendicular sides. Okay. Yeah. So the questions that come from this chapter will be of this type, where you might need to use a graph. Okay. See all the questions. Using a graph paper, plot the points, then reflect it. Use graph paper, plot these points, reflect. Use a graph paper, plot the points, reflect them. After reflecting, join some points that they tell you to join. What shape it is, what is the area of that shape. Okay. Is that clear how to do reflection? Take a minute, go through reflection.
So tomorrow we have to bring graph paper for test.
Yes, bring graph paper for test. There's a word here called covariant. Covariant? Is that the word? You heard of that word?
Collinear.
What? Collinear.
Yes, sir.
There is collinear also. There's covariant also. Collinear means what? Suppose I tell you 3 points are collinear. What does it mean? Or not
They
collinear,
lie on the
invariant.
same line.
Yeah, collinear means what? Points that lie on the line. Okay, so for example, see these 3 points? They're collinear because they are all on one line. Okay. Yeah, the second word is invariant. Invariant means a point which after reflection also does not change it's the same point even after reflection. Now, how can such a point be there? Now, this point, if it reflects on the x-axis, it comes here. Right? This comes here. This point will come here. What about this point here, which is on the x-axis? After reflection, where will it be? It will be right there. Okay. So such a point is an invariant point. Okay? This point is invariant on reflection on the x-axis. On reflection on the y-axis, it will come here. Correct? Yeah. So it's invariant means on a certain axis or on a certain line, it does not change its value after reflection. Okay. Suppose this is 1 and this is 2. What is the coordinate of this point? What is it? 2, 0. 2 on the x-axis, 0 on the y-axis. 2, 0. So the point 2, 0 is invariant on reflection on the x-axis. 2, 0 is invariant.
Can you explain it again?
Yeah. 2, 0. When you're reflecting it on the x-axis, what will it become?
Two comma minus 0.
Yeah, the thing is there's no minus 0. Right? 0 and minus 0 is the same thing. So it's just 0. So 2, 0 will be 2, 0 only after reflection on the x-axis. Therefore, we call this point as invariant. Is that clear?
So
Okay. Oh, also sometimes they call as line of symmetry. So if you draw any shape, for example, a trapezium, isosceles trapezium, it has a line of symmetry. That's a line which cuts the shape into two equal halves. Okay. So some shapes have line of symmetry. What about a parallelogram? Does it have any line of symmetry? No, it doesn't. Line of symmetry means when you fold it on the line, it will exactly fold equally. See, this is a line of, if my hands are like this is the line of symmetry. Because when I fold my hand, it fits exactly. So I can't do that for a parallelogram. You see, this tip will go this side and cross over like, you see. But for an isosceles trapezium, what is an isosceles trapezium? These two sides are parallel and the other two sides are equal in length. Isosceles trapeziums, they have a line of symmetry because when you fold it, it fits correctly. What about a normal trapezium? Like this. This is also trapezium. See, two sides are parallel. It's a trapezium. But does it have a line of symmetry? No. Okay. So some shapes will have line of symmetry. You have to draw that and name that line. Now symmetry is not in course. It's out of syllabus out. Is that what it means? Okay. Anyway. Yeah, so I think
Yes,
we
we don't need symmetry.
touched everything from here. See the last perimeter and all that. You know how to find perimeter of shapes. Find every length, find the perimeter. Now, how do you find the length of everything? See here, look at this. If I want to find the length of this perimeter of this trapezium, okay, what we found the distance of B to B double dash. That was 10, right? And C to C double dash was 4. What about C double dash to B double dash? What is this length? How do you find this length?
distance
You have to use
from
distance formula.
Distance formula.
So any line that is perpendicular or parallel, I mean, x-axis or y-axis, that you can just count the distance. But if the line is like this, a diagonal type of line, you have to use distance formula to find the distance. So for example, B to C, if you want to find the distance of BC, the formula is what? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. That's the formula. One of the coordinates, you'll take it as x1, y1. Other one, you'll take it as x2, y2. Put in the formula and you can find the distance. Is that clear, Aman?
Now, what is covariant?
There's no covariant. Invariant only. Is the word covariant there? Is there a word covariant anywhere?
No, no. I thought it was there.
Yeah, even I thought it was covariant. But it is not covariant, it is invariant. Okay. Invariant is a point when it reflects, it does not change its value. Okay, are we done with reflection?
What is the distance between B to B double dash?
A double dash, A double, just reflections of A. A dash is one reflection of A. A double dash is another reflection of A. They will tell you in the question what is A dash and A double dash. Okay, I think this is enough from this chapter. We'll go to the next chapter. What's the next chapter?